I put a link up there. I tried to make it active for you. Most of you probably already have GeoGebra that were here for the first term. If you were not here in the first term, then you might need to make sure that you download that. I'm going to go over graphing linear systems and nonlinear systems. And we're going to use GeoGebra quite a bit, but I'm going to do the first couple just manually. It's something that you could do on regular graph paper and help if you have a ruler to keep your lines really straight. And then we can always verify our solutions by plugging them in, checking them algebraically. So, but the GeoGebra link's there. There's also going to be a Socrative link as we get near the end of the lesson, where you'll have a chance to go answer some questions, and it'll send us a nice report, and it'll give us some additional data as far as your participation in the lesson and things of that nature. So, all right, let's go ahead and get started here. Like I said, if you need the GeoGebra, just click right on the link there, right under where it says Welcome. We'll be starting at 2 p.m. Eastern Standard Time. And the link again is active. Most of you are on Windows computer. I know some of you use Macs. And if you click that link, it'll take you right there to the download page to the install GeoGebra. If you're using Windows, you just click right on the Windows there and it'll download it. I doubt any of you are using Linux, but they do have the Ubuntu, the Java applet, the Mac. So whichever system you're using, of course, just make sure you download the one that's most appropriate. So far we've talked about solving systems of equations algebraically, both linear and nonlinear, and talked about substitution, elimination, and today we're going to go over graphing. Your quiz that's going to come up pretty soon for most of you is going to be elimination, substitution, graphing. So you want to make sure that you use the alternate assignment that's posted on the message board. Mrs. Gray actually has made a wonderful tutorial that goes with that. I put the alternate assignment up in a Word document and in a PDF. I know some of you use OpenOffice, and we're having trouble opening the Word documents with the actual question showing up. So if you could make sure you do the alternate assignment, you'll find it incredibly easier, much more clear than the assignment that's posted in the lessons. So, all right, let's go ahead and get started here. So graphing by hand, we're going to work both of these systems out by hand. I'm going to try to use my pen tablet and my OneNote to do that. And then for a lot of the others, we're going to do these in GeoGebra as well. So I'll kind of go through not only graphing them to get the solution in GeoGebra, but also all the steps to get your GeoGebra set up. I'll show you the way that it opens by default. I'll show you how to put your grid lines in, how to enter your equations, and everything like that. So you'll need to remember several things here. Back in Term 1, we learned how to just graph a regular line or a regular parabola. So we learned how to graph things by hand. So, of course, do need to remember that. You also need to know how to solve these literally for y in some cases. Luckily, when we do these in GeoGebra, we don't actually have to solve anything for y. We can just enter them the same way that they're entered here, and that's the way that we'll actually do that when we get to the GeoGebra. So let's go ahead and see what we do here. If we're doing it by hand, we're going to need to solve for y. So we're putting it in slope-intercept form, and then we're going to plot our y-intercept and use our slope, make a little graph, and we're just going to look at where the lines intersect. So where the lines intersect is going to be our solution. Like I said, it's easy to plug those solutions in and make sure that you're getting true statements when you plug your x and y value in. That's the way we check our answers here. So even if I graph in GeoGebra, I'm going to take the time to go back and make sure that it's correct by checking my answer. So you're going to see the OneNote come up here for you. So what I've got here is just a little grid, and like I said, I normally would be doing these on graph paper by hand with a ruler, so I'm not sure how linear my lines are going to look trying to draw them freehand here. But anyway, so to get them both in terms of y here, for this one, for example, we would just, you're always going to do the opposite of whatever they're doing to your variable that you want to isolate. So here you can see 9y, they're just multiplying the y by 9. So that's not too bad. All I have to do is the opposite of what they're doing to the variable I want to isolate. In this case, I'm going to divide each side by 9. So you need to be careful when you're dividing by 9, because see on the right-hand side I've got actually two terms. So in that case, I've got to divide each term by 9. So over here on the left, 9 divided by 9, that's pretty easy because that's just 1. But on the right-hand side, you can see I'm going to have 6/9 minus 36 divided by 9 is 4. So the 6/9 x, the 6/9 I can reduce. I don't really want to be counting out a slope and rising 6 and running 9. We'd certainly run out of room in a hurry if we did that. So the 6/9 actually reduces. They're both divisible by 3. That'll reduce to 2/3. So the equation I'm actually graphing is y equals 2/3 x minus 4. All right. And unfortunately, I'm unable to really see the chat, so if I'm messing up, I know Willie will tell me. Willie or Emily or somebody, get a few people that kind of make sure I'm doing these correctly. So I'm probably not going to be able to see you until after we pause and go into the other area. But anyway, let's go over graphing this line, 2/3 x minus 4. I'm going to go down to -4 here on my y-axis, make a little point there, and then I'm going to just rise 2 and run 3. I usually make 3 points total, so I'm going to rise 2 and run 3 one more time here. And I think this actually has the functionality to make a straight line, but I'm not too good at that. So I'm just going to try to freehand this, and like I said, it's probably not going to be a very straight line, but it's going to look something like that. Like I said, if you do it on paper, I would use a ruler or compass or something like that to make sure you're making them really straight. So, all right, this next one here, think about our steps to 3x plus 3y equals 3. I'm thinking of the steps to isolate the y there, because I want it in y equals mx plus b form. If you need that in your notes, by the way, I'll write it up here in the right-hand corner, y equals mx plus b. That's something you've probably learned over and over and over in all your math classes for many years. But the m is the slope, which is rise over run, and the b down there is the y-intercept. All right. So for this one, I'm going to subtract 3x from each side. That's going to leave me with 3y equals negative 3x plus 3. I could have written, 3 minus 3x, but I want it in that slope-intercept form. So I want my term that has the x variable there on the left. On the right-hand side, I want it in this spot on the left. So now to isolate the y, just divide everything by 3. Don't forget here that every term has to be divided by the 3. Okay? So negative 3 divided by 3, that's just a negative 1. And then positive 3 divided by 3 is just a positive 1. All right. So from here, same thing. We're going to plot our y-intercept first. And our slope's a negative 1. Sometimes get questions about a negative slope. Well, what do I do with a negative slope? Do I rise negative? Do I run negative? Do I do both negative? Keep in mind, that if our slope is negative, it means the line's going down from left to right. So I can't rise and run negative. I'm going to do one or the other. I personally always do my rise negative if I have a negative slope. In other words, that way I can remember the rule as I'm always running positive. So slope is -1. If the slope's -1, I'm going to write that as a fraction because I want to know how much to rise and how much to run. So to write -1 as a fraction or any value as a fraction, I simply write a 1 under it. So I'm going to rise -1, run 1, rise -1, run 1. Normally I would just make 3 points here, but it looks like if I do one more rise -1 and run 1, I'll actually end up on that point right there, which will be my solution. So then I'm going to make a line, horribly unstraight line. I apologize for that. But it looks like my solution here is 1, 2, 3, and then 3 for the x value. And they cross right here at a y value of -2, it looks like. So 3, -2 is what it looks like there. So let's see here. Like I said, we can always check these answers. Plug a 3 in for the x and a -2 for the y. Make sure it works to give you true statements in both of these. So let me go ahead and do that real quick. So 9y, that's 9 times -2, equals 6x, and we found x to be 3, minus 36. So 9 times -2 is -18, equals 6 times 3 is 18, minus 36. So -18 equals -18. 18 minus 36 is, of course, -18. So it works perfectly there. Comes out with a true statement. But remember, it has to work perfectly in both linear equations. So just checking one doesn't do me any good. I've got to check both of them. By the way, I could check it in this form here, or I could check it in my original form, what I started with up here. It doesn't matter. I checked the first one in the original form because the reduced form's got a fraction, so I'm going to try to avoid calculations with fractions when it's possible. But it looks like the other one, remember these are all equivalent forms, so although I'm writing them a different way, they're still 100% equivalent. They're the same thing, I'm just representing them in different ways. So I can take this y equals -1x plus 1. I could plug my solution set in there. So let's plug in the -2 for the y equals -1, and then x is 3 plus 1. -2 equals -1 times 3 is -3. And you can see here you're going to get -2 equals -2. So I've checked it in both, and the solution there, the point of intersection, actually solves both of the linear equations. So it looks like we're all set there, and looks like we did a good job. So, all right, let's go ahead and look at the next one here, and then we're going to do some nonlinears. Oh, I told you that I would do that in GeoGebra too. Let's go ahead and just put that in GeoGebra now. You have a chance to do some of these in GeoGebra here in a bit. We're going to do some, approximate values in GeoGebra as well. But just wanted to give you an idea of what we have with GeoGebra. It's basically a free graphing calculator. And like I said, those of you that were with us in Term 1 probably already pretty familiar with GeoGebra. You've used it on a few different things. So when I first opened my GeoGebra, it was a little box over here. I just clicked over here on the blank part of the screen to make the box disappear. But you'll notice there are no grid lines, and it's also not really sized in the best way. It doesn't look like. I like to make it a little larger here, so I just take and grab a corner and expand that a bit. Now you'll notice my X and Y axes are not centered, so over here on the far right I've got a Move Graphics view. I'm going to click that, and it turns into a little hand. I can just grab, I left click, and kind of move it around where I would like it to be. And then let's make sure that we're showing our grid lines here. To do that, I'm just going to right click, and it says grid here. I'm going to select grid. If you're using a mouse to zoom in and out, you can just roll your mouse wheel up or roll your mouse wheel down, just like that. So I'm going to leave it about right here. So remember I said we actually don't have to put these in slope-intercept form for GeoGebra. So I can just type it the way it was presented. So the first one was 9y. You can see down here in the bottom left in the input bar, I'm just typing my equation. 9y equals 6x minus 36. And I hit enter, and it's going to put my line up there. I'm going to show you how to label these lines and label the point of intersection as well. We're also probably going to move this around a little bit so we can really focus on that point of intersection. That's really what we're looking for when we're solving these systems by graphing. So let me put the next line in here, and hopefully it doesn't remove my first line. We'll see if it does. If it does, I'll have to put it in a different way. But the next one was 3x plus 3y equals 3. So a lot of 3s, 3 3s. All right, and then hit enter. Okay. So it did it. Let me put both of them in, and one is A, one is B. So this is the point of intersection right here. In this case, it's pretty easy to just look and see that 3 comma negative 2 is our point of intersection. That is our solution for this system. But just to be sure, I'm going to use this function over here. You see the little blue dot with the capital A. I'm going to click on that, and it's going to give me a little drop-down menu there. And I want to intersect. This is going to tell me where these intersect. I'll show you that process one more time. I go to the capital A with the blue point there, and I just hit my drop-down arrow, and I'm going to go to intersect. Also notice this is highlighted with the blue border, so I'm doing an intersection. After I click intersect, I'm going to hit the first line, then I'm going to hit the second line, and then you'll see it puts a little point A there, and over here it actually gives me the coordinates of that point. So when you do your quiz, and as I say, Mrs. Gray has a very wonderful detailed tutorial on this, but I'll show you real quickly. To label these, I'm going to go back over here to the little mouse pointer icon. I'm going to click that, and I can actually drag these equations and put them by the lines. Okay, this one actually corresponds with the line down here. You can see way down here in the bottom, it's got a little A by it. Up here it has a little B. That way if you're unsure which graph goes with which equation, you can always look at that. So I'm just going to move my graph right here. So I'm labeling that line is negative 2x plus 3y equals negative 12. Also notice neither of these came up the way that I entered them. It actually is going to put them in the simplest form for us. So point B, I'm just going to grab it here, left click, and drag over. And I have that line labeled as well. Well, how about the point here? I'm going to do that a couple ways. I'm going to show you how to just go right to the point, right click it, and it gives us a little extra menu here. I'm going to go to Object Properties. And here where it says Show Label, right now it's showing the name. It tells you up here the name is A, but I want it to show the name and the value. Okay, so that's going to give me the actual coordinates. Now when I close this out, you'll see here that it actually labels the point 3 comma negative 2. So we can export that and put it into a Word document and everything like that. And I've got a couple tutorials on the blog on how to do that as well. So that's how we do it in GeoGebra. A bit easier, I think, to do it in GeoGebra, especially if you're like me and have a lot of trouble drawing straight lines freehand. So well, let's go ahead and do one more of these, and we'll start to try some of the non-linear. I think I've got a couple word problems set up for you here as well. So, all right, so let's go ahead and scroll down here. So even if we're doing these in GeoGebra, like I said, it's still a good idea to just check. If you want to check your answer, be certain that you've entered everything incorrectly. That's always fine. So let's go ahead and move on to this next problem here. So 2x minus y equals 5. And the reason I wanted to show this one is I see a lot of errors on a couple things isolating the y on these times. But let's go ahead and get the y by itself. So we're going to subtract the 2x from each side. So where I see an error, some students will drop that negative off the y. When I bring this down, it equals negative 2x plus 5. But we haven't solved for y because we have solved for negative y. So we remember coefficients. We don't write 1 or negative 1 coefficients here. So this is actually negative 1y. So the y is being multiplied by negative 1. So I'm just going to do the opposite of multiplying by negative 1, which is dividing by negative 1. All right, so negative y divided by negative 1 is just going to give me a positive y. So basically all our signs are flipping here. Negative 2 divided by negative 1 is a positive 2. So positive 2x, and that plus 5 is going to turn to minus 5. And of course you get better and better at these the more you practice them. So any chance you get to practice, 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 and of course they have all of those extra practice problems for you to try out there in the lesson as well. So show you a couple things that I see on this. I included both of these just to clarify a couple things that I've been seeing errors on. So let's get the y by itself. We're going to subtract the x from each side. That gives me 4y equals negative x plus 8. I've had some questions about this. We're going to divide everything by 4 here. But what we get is y equals negative x divided by 4 plus 8 divided by 4 is 2. Now, this is where I see the questions come, right here. Because a lot of time, even in your lesson, it might not write it quite like that. And there's a real long explanation and a short one. So I think I'll go with the shorter one here. So this negative x over 4, remember negative x, that's the same as negative 1x. Just like that. Also remember when we multiply things by fractions, we simply multiply straight across. The way that you're going to see this written for y equals mx plus b form is negative 1/4 x. So all I've done, and this is what you're looking at here, is 3 different equivalent forms of negative x over 4. We could have negative x over 4. We could have negative 1x over 4. That's just adding that coefficient. It's an assumed coefficient. And then we also have it written this way. So if I were to ask you to multiply negative 1/4 times x, let me show you what would happen here. We'd have negative 1/4 times x. Some of you might like to write the x as a fraction, and then you just multiply straight across. So you get negative 1x over 4. We're kind of doing that. We're just going backwards here. So we are going to see it in this form here, most commonly. Okay? So let's go ahead and graph these. We'll graph the y equals 2x minus 5 first. So down on my y-axis, I always plot my y-intercept first. Negative 1, 2, 3, 4, 5. That's down here. My slope is 2. So if you want to write your slope as a fraction, it's just 2 over 1. So up 2 over 1 and up 2 over 1, just like that. And then we draw that line straight through those. Like I said, make sure you draw really straight lines. Don't draw them like mine. It's a good thing I'm not the art teacher, right? So, all right. So let's do this next one. Remember, we are using negative 1/4 x plus 2. So I'm going to start up here at 1, 2 on my y-axis. Then I'm going to graph the slope is -1/4, so -1, and then 1, 2, 3, 4, that's over here. And I'll always make a third point as well, -1, 1, 2, 3, 4. And we're going to draw a line through that. Well, this one's a little more difficult to see. I'm hoping it's right there at 3, 1, but I can't be sure. So like I said, if you did this on graphing paper with an actual ruler, you're going to get a lot closer than I am trying to draw these lines by hand. But let's go ahead and check it in GeoGebra. Looks like it's right around 3, 1. You know, we could plug those values in and check them. Okay, but it'd be quicker just to try GeoGebra here. Let's see what comes up. So, another thing here, when you're using the GeoGebra, I can just right-click these and delete them. So I just right-click on the point, delete, right-click on the line, delete. So now I've got a fresh start here. I can kind of put these other equations in. Unfortunately, I forgot the second one. Let me write that down. The second one was x plus 4y equals 8. All right. Here we go. So first one was 2x minus y, down here in the input bar. 2x minus y equals 5. I hit enter. There's that line. And then the next line was x plus 4y equals 8. Enter. Oh, it doesn't look like it's right at 3, 1. Okay, so this is more than likely going to be a situation where we can only give an approximation of the actual intercept here. So let me go ahead and click over here again. Remember, I'm going to intersect the two objects. Click the first one, click the second one, and it gives me the point. Yeah, these look to be possibly irrational numbers. I've got the GeoGebra set to only go out to 2 decimal places, and you can set that to go, I think, up to 5 or 6 decimal places. So this is a good example where we're only going to have an approximation. In other words, this is not 100% exactly what the actual intersection value is for the x and the y. If you've got a really good calculator, sometimes you can turn these into fractions, if you have a TI-84 or something like that. But if you have a 0.11, I don't believe that's going to translate nicely into a fraction. It would probably be 311 over 100, something like that. So in this case, it's an approximation. So we've got 3.11 and 1.22. By the way, we're going to do this same type of thing with nonlinear, and you're going to see a lot of different approximations that we're going to run into there. So let's go ahead and go back to the one note here. So it's going to be something that's also going to eliminate our ability to check these really in a nice way, because we only have an approximation. Typically your questions, they'll ask you to give the approximate value and things of that nature on there. Okay? So in this case, we've only got approximate values. I would write it probably with a little squiggly. This means approximately. Some of you that had geometry already probably remember that. But 3.11 and y is approximately 1.22. And as I said, those are probably not values that are going to work really well with putting into a fraction form. So we could also try to solve these. It wouldn't be too hard to do elimination on these. So, all right. So now let's go to this word problem. what I'm doing with the word problem here, most of the problems I see are students ask me, they get stuck on the actual setup. And that seems to be the hardest part. Okay, so let's take a look at this one. Find the width and length of a rectangle whose perimeter is 36 feet and the area is 77 feet squared. Typically, when you run into the word problems, you'll see things, some of you back in probably middle school or earlier, you had to do area of a rectangle, area of a triangle, all of these things. They expect you to remember all of that stuff. Well, fortunately for us, the area of a rectangle, that one's pretty easy because it's just length times width. Okay, so we're going to set this system up, and we're actually going to solve this system by graphing it. Okay, and this one's going to have an interesting answer, to say the least. You're going to get 2 correct answers. I just tell you that in advance. All right. So if I'm going to write this where I could enter it and say GeoGebra or something like that, I'm going to have to use X's and Y's. So usually with any type of word problem, I start by identifying my variables. So I'm going to say X is the width and Y is the length. Okay, so we always want to identify variables to start. So rectangle, it sometimes helps if you draw a little kind of a picture tutorial with it as well. Let me put just a little basic rectangle over here like that. So we say perimeter. Perimeter is adding all the sides together. So let's say if I say this is the width and this is the length, and really width and length are interchangeable. You don't need to really worry about which one you call width and which one you call length. Because like I said, we're going to get some ironic answers when we get to the end of this. But anyway, so if I've got one width over here, one width over here, and a length down here, and a length up here, the perimeter is all those added together. So the way I would write that is 2 times the width plus 2 times the length equals the perimeter, which in this case is 36. And then the area is just length times width. So I'm just doing X times Y. And the perimeter here is 77. All right. So when you look at these, so this is still on solving systems of linear equations by graphing. These are not nonlinear. This is actually going to, even though it doesn't look like it right now, X times Y equals 77. Pretty sure that's going to come out just a line with a really wild slope. So, all right, let's go ahead and get our Y by itself here. This length should be a Y, by the way, over here on the top equation. Just divide everything by X. So Y equals 77 over X. And then the first one, it looks like if my slope is 77, doesn't look like something I'm going to be graphing by hand anyway. Because as you can see, I'd have to start at 0, and then I'd have to go up 77 and over 1. So these don't look like they're going to be very friendly for graphing by hand. This will be a good example of a time where we actually need to use the graphing technology. So let's go ahead and put these into our GeoGebra and see what we get here. All right, again, I can remove these ones that I had before. All right, and let's just put these new ones in. So we had 2x plus 2y equals 36. That was our perimeter. And you can see, I'm glad this happened. You'll notice that you see no line anywhere on here. This is where we have to resort to that zooming in and zooming out. If you don't have a mouse where you can just roll the wheel to zoom in and out, you can click the little far right icon and you have zoom in and zoom out options here. Zoom out. It turns my cursor into a little magnifying glass with a negative sign in it. So I'm decreasing the zoom there. Okay, but it's easy if you have a mouse, just roll the mouse wheel up and down. All right. Now let's put our other equation in. It was y equals, and 77 over x, I believe it was. Oh, okay, that's not going to be linear. So since the x is in the denominator, it's actually irrational. Look, in this case, let me zoom in on the intersection here. This part of the rational equation down here, it doesn't look like the line touches it at all. I can zoom way, way out. And it looks like it only touches right here. So let me zoom in. Let me also correct my error from before. So we obviously have moved to systems of nonlinear equations. Although one of these is linear. But I'm going to zoom in. I keep kind of moving and rolling my mouse wheel up to zoom in right here where these intersect. Okay? So it looks like I've got two intersections, unfortunately. And this is what I was telling you about. The answer is going to come out kind of strange. But anyway, let's go ahead and intersect the two objects here. We click intersect, then the line, and then we click our rational function there. But look, it only gave me 1 point here. I can clearly see it intersects down here as well. What you're going to do when that happens is click your intersect again, and now I'm going to click below this other intersection point, so the rational function and the line. Then you can see it gives me my other intersection here. Now here's the problem. I've got two solutions. I've got x equals 7 and y equals 11, but then I've got x equals 11 and y equals 7. And the reason for that, like I was telling you when we actually initially wrote our, we drew our little rectangle out here, I said, well, it doesn't matter if you put the width here, the length here, right? So they're interchangeable. In other words, it's just the length times the width. So it doesn't matter if the length is 7 or the width is 7, right? So you have actually two ironic solutions there. So, and of course, if you run into a question on your test like that, you know, just hopefully they would only have one of those options for you to select. So, all right, let's do another nonlinear. This one looks like it's going to be something that is not going to, let's see, maybe it will work out with some exact solutions. But I wanted to show you a couple things here. We're not really graphing circles in Algebra 2 anymore. I don't know why they removed that. But when you see these x squared plus y squared equals a number, those are actually circles. It used to be a very complex process to enter them into graphing software, but not anymore. Now we can actually just punch it in just like it's written there, x squared plus y squared equals 4. And it'll actually put the circle. So in other words, we used to have to solve for y, which would give us a positive and negative square root of something. And you'd get two semicircles and have to put them together. But fortunately for us, now we can just punch it into GeoGebra exactly like it is. So the other one here you should recognize from Unit 3, I believe it was, in Term 1. That's just a parabola. All right. So, yeah, and I saw Mrs. Gray's comment there. You're typically not going to graph these by hand. If you do have to graph them by hand, you know, we could do a few things. We could put that into vertex form and graph our, you know, vertex and their axis of symmetry and all that stuff. Another thing to remember, you can always make an x and y table. The problem is with the quadratics, I would really want my vertex before I made my x and y table because I want to use points to the left and points to the right of the vertex. So we do know that it's going to have a y-intercept of 2, so I guess that's helpful. All right, so let's go ahead and see how we put these into GeoGebra. If you guys want to punch them into GeoGebra on your own and find these intersection points, that's fine as well. So I'm going to be going through the process here. Those of you that are comfortable with it, you can just go ahead and go right into your GeoGebra, put these two equations in. You might want to write them down first because I'm not going to have this screen up. we want to write those two equations down and put them into GeoGebra. And I know many of you will be far faster than I at coming up with a solution there. So let's go ahead and back to GeoGebra. So here we are. And again, I'm going to remove all of these old points, all of the old graphs. All right. Now look, I'm kind of in a strange place here, so I'm going to have to zoom back out, find my X and Y axes here. Here we go. So let's do the circle first. The circle looks fun. So I'm down here in the input. So X squared, remember to use your little caret symbol there. That's right over the 6 key on your keyboard. So I hit X and then Shift 6 and then 2 for X squared. And it was plus Y squared equals 4. So that's a circle with a radius of 4, and I'm going to move this around so we can get a little better look at that. Okay, so I'm centering it here. And now we know the other one's going to end up being a parabola, so let's put that one in. That was X squared minus 3X plus 2. And I hit enter there. Let me see, I'm looking at the chat box there, and I don't see anybody coming up with the answer, so I don't know if you guys are feeling too comfortable with the GeoGebra yet. Or maybe I went too fast, I'm not sure. Right, so let's go ahead and intersect these two. So I hit intersect, I click my parabola, then I click my circle. And ironically, different than when we did our rational function with the linear function, it only gave me 1 point. This one gives me 2 points right away. And there's a question, I'm pretty sure you have a question similar to this on your Graphing Systems of Nonlinear Equations assignment. Isn't that right, Mrs. Gray? I think we had actually one that we submitted a help ticket on. So good example then, because you're going to see something very similar to this, and this is exactly how you do it. You know, if we're turning this in on an assignment or something like that, like I said, we can always remember to click your little mouse icon up here first, but you can actually go and label these. That's the circle. This is the parabola, just like that. And then our points, remember, right-click, Object Properties, and then show the name and the value. You can even just show the value if you wanted. I'll do that with this other point. If we only wanted the value, you could just put the value in. So it says 2.0. It's kind of hard to see. Sometimes you'll notice they're not showing up as large as you'd like them possibly. You know, sometimes you'll have the option to change the size, but on your actual points, I don't believe you do. Let me show you on the actual function, though, on this quadratic. If I go to the click on the actual quadratic function there, the equation, and I can go to text, and I have some options to make that a little larger. You can see it made it much larger now. So if I'm turning this in to a teacher or something like that, I want to make sure they can see that I've correctly graphed and correctly labeled my graphs. All right, so, all right, you guys want to try some approximations for me on GeoGebra on your own? That sound like a good plan or no? Yeah, Mrs. Gray, I remember that. And hopefully it'll be corrected. So, all right, let's do let me see if I've got any more listed here that you guys could try. I'd like you to try one. We're about finished up. I'd like you to try one, though. See how many of you can kind of make this work for you in the GeoGebra. And then if you run into any, difficulties, answer. Now, I'm going to give you one that's going to only come up with approximations, so it's fine to just round these out to say, let's say to 2 decimal places. Right? So that'd be to the nearest hundredth. So we'll do y equals x squared plus 7x minus 4. And then for the other equation, let's do another rational. I'm going to use function notation on this one. Let's say g of x equals x minus 4 over x plus 7. I'd like you to give that a try. Don't forget the proper use of parentheses while you're trying to put that rational in. So I'll give you about, what, 2 minutes? Would that be good for everybody? We'll do 2 minutes here. And this is great if you could set the timer for 2 minutes. What we'll do is give you a couple minutes. I want to see what approximations you come up with. By the way, remember, it might not intersect at any points. It might intersect at only 1 point. It might be 2 points, 3 points. So make sure you're looking at every intersection there. And you might also run into a situation where you're having to do maybe intersect the object more than once. That's just a hint. So we'll do 2 minutes, guys, and try to put these two in GeoGebra. You might want to write them down first. And let's see what we come up with, okay? Oh yeah, guys, I should have mentioned that. This is great. Thank you. You can just type your answers right there in the chat box. Emily, try to zoom out from your graph. See if you have some additional intersection points there. And Devin, I see you have 3 intersection points, which is correct. Hint, hint. There are 3 points of intersection. I see Kayla is coming up with very similar answers to Devin. I'm not sure. That is true, Aspen. It'll be 3 different ones. Here it is. That is correct as well, Emily. All right, let's go ahead and let me go ahead and put this one in. And I think I probably should have mentioned before. I know we've been over this in some lessons a few times. But when we have the rational, you see the x minus 4 divided by x plus 7. We have to be very careful about the way we enter that. This is one of the reasons that you've probably seen on your feedback of some of the lessons, especially dealing with rational expressions and rational equations. You might see the feedback that says, well, hold on, let's make sure that we're using our parentheses correctly here. And here's the reason. And I'm going to show you both ways, and this is an error that I think some of you may have made. So first, let's go ahead and get the quadratic out of the way. So y equals x squared plus 7x minus 4, enter. So that's a parabola, that's correct. You can see here, I mean, easy thing to always find out is where's my y-intercept, -4. So that looks to be correct to me. So that's the first one. And now let me show you the second one, because this is an error that I see a lot. And watch the input bar exactly the way I have to put it in. And I'll go ahead and just call this one g of x. I saw someone mention you could just put y, y equals, that would be fine as well. But let me show you what some students do, and this is not correct. But they'll do x minus 4 and then a / and then an x plus 7. Now I'm going to hit enter there. That gives me a, it still gives me a rational function actually. Okay. But look at up here where it tells us what the rational function is. That's not the question that we have. We have quantity x minus 4 divided by quantity x plus 7. So we didn't put our, we didn't use parentheses properly. So this is what we're telling the graphing software. We're giving it a completely different equation than what we're supposed to. Now, let me show you exactly what we're supposed to enter in as far as typing it in. So x minus 4 over x plus 7, we have to specify, if we're writing this horizontally, open parenthesis, x minus 4. That means that entire numerator is x minus 4, and the entire denominator, x plus 7. This is the way we're going to have to enter it. Otherwise, we're giving it a completely different equation. This is critically important because as you move on beyond Algebra 2, and as a lot of you will be in college algebra and things of that nature, I've got a few of you that are probably going to be dual enrolled in college algebra next year. You're going to be depending on graphing software quite frequently. But if you're not entering the values into the graphing software correctly, then you're going to run into problems. All right, so let me delete this one, and let's put it in with the proper use of parentheses here. So g of x equals, open parenthesis, x minus 4. Do you notice when I hit the open parenthesis, it actually puts the closing parenthesis there for me. So then I put my forward slash for division, and then I'm going to put my x plus 7 in parentheses on the bottom and hit enter. Now you'll see that we have a very different rational function that comes up on our graph. And I saw a lot of you said it intersects in 3 places, and yes, it does. So let's find out what those intersections are. I hit intersect, hit my parabola and this rational function. And again, you see it gave me all 3 points. I didn't have to go through that process multiple times, thankfully. So, and then I saw a few of you that did have this correct. So those are the actual solutions. Remember, these are approximations. Ironically, point B is, a very normal solution, -6, -10. And that's something, again, guys, we can plug that in, and we can check and say, okay, well, does it work? You could plug those values, -6 and -10, into both of those equations, and you should come up with true statements there. So, all right, we are getting close to the end. I did set up a Socrative for you guys. Now, you can use, if you have an iPad or, even a mobile phone or anything like that, you can actually use, use those. This is very friendly with mobile technology, and you could go in. There's about 7 questions on there, just multiple choice. Ask you about the lesson, ask you about a couple things, and you'll get to the last question. Sometimes when my students do this, they say, well, it says they're waiting for the teacher to start another quiz. After you do the last question's actually going to tell you that after you finish this, you can exit. So you just, after you finish the last question, just hit the little log out button there. All right, and I'm going to try to put the active link up here for you in case that one's not working on the slide. And when you get to this link, you're just going to enter that room number, 282309. Well, see, it's not making it an active link for me. So just type it in, m.socrative.com. And then, like I say, you could just enter the room number, and you'll see all your quiz questions there, and you can get started on those. Shouldn't take you very long at all. All right. And that will do it for today, guys. Just finish the Socrative quiz on your way out. I'll be sending, I get the results sent to my email, and I will forward the results to your teacher. So I know Mrs. Carmichael's out of the office today, but I'll send them to Mrs. Carmichael and Mrs. Gray, and then I'll, of course, have mine as well. So thanks for coming, guys. We'll have the recording link up on the message boards as well for those of you that might want to be able to slow it down and pause it as we go through those steps to graph and GeoGebra. Thanks for coming.